All right, so we've been looking at matrices as a way to solve a system of equations. But now what we want to do is start looking at them in a more general way and talk about doing algebra with matrices. So we need a way to refer to a matrix in kind of a shorthand way. Right? So typically, we're going to refer to matrices with capital letters. So let's say, for example, we have the matrix A, and this is A11, A21, A M1, A12, A1N, 2. Just fill in all the steps here. Let's say we have this matrix A, right? What we're going to do as sort of a shorthand for this is we're going to refer to this by Aij in brackets. All right? And this is just a shorthand way of saying A is the matrix made up of the entries Aij. Okay? This will just be our shorthand for it. So, using this, we can start writing down statements in a lot more compact way. So, for example, definition here. All right, two matrices, A equals Aij, and B, which we'll say is Bij. Okay, these are equal if they have the same size and remember, the size of a matrix is the number of rows by the number of columns. Right? So if they have the same size and, actually let's specify the same size, let's specify that it's m by n, okay? And Aij equals Bij for all. So for I between, for all I between 1 and m, and j that are between 1 and n. So any combination of I and j from this range, we want these entries to be equal. So for example, if we have A equals 1, 2, 3, 4, B equals 2, 3, 1, 4, C equals 1, 1, 2, 3, 3, 4, and D is 2, 3, 1, 4. Right? Let's look at some options we have here. So here, the matrix A is not equal to the matrix B because the first entries are different. The 1, 1 entries are different. Right? On the other hand, B is equal to D because every single entry in this matrix matches up. Okay? So even if all the numbers are the same in the two matrices, if they don't match entry for entry, so the 1, 1 entries have to match, the 2, 2 entries have to match, the 1, 2 entries have to match, the 2, 1 entries have to match. They all have to match each other. Right? Just like two vectors, right? The first components have to match, the seconds have to match, the thirds have to match, and so on. Also, A is not equal to this one is because they have different sizes. Right? And different entries as well, of course. In fact, let's even change this a little bit to have 1, 2, 3, 4 here. So even though all of these entries match up, 1, 2, 3, 4, 2, 3, 4, the 1, 1, the 1, 2, the 2, 1, and the 2, 2, those all match. But because these are different sizes, there is no 3, 2, or 3, 1 or 3, 2 entry here, while this one does have it. Can't be. Okay? So there's more statements we could write down here, but the whole point of what we need to know is they have to be the exact same size and all of the entries have to be exactly the same. All right. So once we have that, let's talk about another matrix operation here. If we have two matrices, how do we add them? Matrix addition. Okay. So if we have two matrices which are the same size, we can just add up their components. It's much like adding up two vectors. So if A is the matrix Aij and B is the matrix Bij, are m by n matrices, right? Matrices of size m by n, then their sum is the new m by n matrix, which we call A plus B, and the ij entry here is Aij plus Bij. Right, so what we're saying is this new matrix that we made, the ijth entry of that is just equal to the sum of the ij entries in the original matrix. Right? So for example, right, if we have 1, 1, 2, 1 plus 0, negative 1, 3, 9, right? This matrix here, we're just adding together the corresponding entries. So top left plus top left, bottom left plus bottom left, top right plus top right, and bottom right plus bottom right. Okay? And so this matrix is 1, 0, 5, 10. Okay? On the other hand, let's look at something like, I don't know, 2, 1, 3, 0, 6, 6, plus 1, 1, 2, negative 1, negative 1, 3. How about this one here? Well, these have different sizes. And since they have different sizes, this is undefined. Hopefully that makes sense. Now there's one more simple operation I want to talk about with matrices here. So hopefully matrix equality and matrix addition are pretty straightforward. We want to talk about scalar multiplication now. Okay, so scalar multiplication. Okay, so what is scalar multiplication? Well, if A equals Aij is an m by n matrix, and C is a scalar, okay, then the scalar multiple of A by C is the new m by n matrix that we call C times A. And just like with vectors, if we take a vector and we multiply it by a scalar, it multiplies every entry of the vector. So when we're talking about a matrix, we multiply a matrix by a scalar, it's going to multiply every entry of that matrix by said scalar. Right? So, as an example here, let's say we have 5 times the matrix 1, negative 3, 2, 0, 7, 1, minus 4, 0, 0. Okay? How would we compute this? Well, we would, so 5 times 1, 5 times negative 3, 5 times 2, 5 times 0, 5 times 7, 5 times 1, 5 times negative 4, 5 times 0, 5 times 0. Right? So just compute all those. 5 minus 15, 10, 0, 35, 5, negative 20, 0. Right? So we just multiply every single entry in the matrix by that constant, by that scalar. So I'll let you think about how you might define matrix subtraction. Right? Really, it's a combination of addition and scalar multiplication, where you multiply... Actually, I'll let you think about that. Think about how you could define A minus B. I'll tell you, you compute it in exactly the way you think. You take the entries of A and you subtract the entries of B. Right? Just like addition, they have to be the same size. And you subtract corresponding entries. So hopefully that all makes sense. And I'll see you in the next video for some matrix multiplication.